Actually, the first laptop that, well, I don't know if it's actually the very first laptop, but I do remember seeing a laptop like the size of a briefcase. So that was back in the early 80s. Okay, so good morning, guys.
Yeah, I think when the first laptop was invented in 1977, they like had it like a briefcase. That's how you would close it.
No, didn't it have like processors that took up like 1,000 square feet?
No,
That was
the
very first.
That was the first computer, but the first laptop was condensed. It was portable, but it was kind of clunky.
Yeah.
Okay, so what I want to do with you guys today, if there are no questions about any prior assignments, I will go over the enrichment problem that I posted over the weekend. If you do not have that in front of you right now, I encourage you to just open up that weekly pacing calendar that I always post up on Mondays, right? Just open that up in Google Classroom. And within Google Classroom, within that posting, you're going to see any different problems listed on there, right? The first of which, I want to share my tablet screen right now. Let's see here. Okay. So I'm going to go over here and present my screen. Do you guys have the that pacing calendar opened up?
It's loading. Yeah. Yeah. Okay. Yeah.
You got it. All right. So so for today, okay, what I'm going to do is that very first one, which was a series of questions. Actually, it was something like this. It was like, find the area of an equilateral triangle with a side length of S, right?
Yep.
And it said to express it in simplest radical term. Was that right?
You reduced it in radical form. Yeah.
Okay. So what I want you to do, I want you to think about this, okay? And let's take a look. So we have an equilateral triangle, and everyone is capable of doing this. So I encourage you, okay, to pause and think along with me here. You have an equilateral triangle. The side length here have side length of S. Is that right?
Mm-hmm.
All right. And there are a couple of ways that you can approach this. We recognize that the area of a triangle, okay, is given by 1/2 base times height, right? This equals to the area. So immediately, what's the base here?
The base is S.
The base is S. So I know that this is 1/2 S. And the tricky part here is figuring out what H is, right? How do I find out what H is? And there are a couple of ways that you can approach this.
You can use trigonometry and use sine or cosine. Or
That's
tangent.
right. You can certainly use sine, cosine, tangent. Okay, so if you do that, wait, what's this angle over here that I just drew?
60.
That is 60 degrees.
Yeah.
Okay, and there are a couple of ways that you can approach this if we are to go down the track of using trigonometry. Okay, if that is 60 degrees, and we're solving for this that length there that's dashed. Okay, I'm going to call that H. What are we going to do? What are we going to use? Are we going to use sine, cosine, or tangent to figure out what H is?
Sine.
Emmett?
Sine, right? It's the opposite.
Sine, because H is opposite of 60, and we know the hypotenuse, because this is indeed a right triangle here, right? The hypotenuse is length S. So we know that H over S is equal to sine of 60. And sine of 60, okay? This was, we covered this, I think maybe 3 weeks ago, okay, I would say. So sine of 60, okay, what is that? There was a radical value, okay? And if you don't remember what that is, okay, sine of 60, it was actually square root of 3 over 2. Okay. So sine of 60 is equal to square root of 3 over 2. Now, when we went over this, okay, like 3 weeks ago, I'm just going to remind you, okay, we had sine of an angle, and here are all the angles, right? We have 30, we have 45, and then we had 60, right?
And that's definitely that note sheet is definitely in the minefield of papers that are on your desk.
What was that?
Wait,
Emmett, what was that?
I said that note sheet is definitely in the pile of paper on my desk.
Yeah,
Ricardo, can you mute your mic? You're making a lot of noise.
yeah. Thank you.
Am I?
Yeah,
Yeah,
there's like
we
a
hear
tapping
your
or something.
tapping.
Yeah.
So sine of theta is sine of 30 is equal to 1/2. Sine of 45 is radical 2 over 2. Sine of 60, well, that's just radical 3 over 2. And then we had cosine of theta, right? Cosine of 30 is radical 3 over 2. Cosine of 45, radical 2 over 2. Cosine of 60 is equal to 1/2. And then the last thing is tangent.
Was that radical 3?
No.
So tangent,
Yeah.
1/3.
tangent of 30 is radical 3 over 3.
Oh.
Tangent of 45 is 1. And tangent of 60, well, that's just radical 3. So you're looking at this chart and you're probably wondering, like, boy, I mean, we haven't really like seriously used this this year. I mean, it was introduced to us, but you know, we really haven't like delved into it that much. And I would agree with you on that. Okay, but when you guys enter into Algebra 2 next year, okay, that chart that I just made there, that thing that's boxed in, okay, those values needs to be internalized. If you are ever deciding to take like the SAT 2, or if you want to, you know, do really well on those like subject tests or ACT, okay, the math section, okay, they tend to test you, okay, a lot on your understanding of trigonometry, and in particular the use of that of the information in that chart. So again, that chart there, really important. I'm just going to put a star there because you do need to know that. Okay. Anyway, getting back to our endeavor here, okay, we need to find out what H is in terms of S. So what are we going to do in this case? We're just going to simply cross multiply, right? So what will H equal to here?
H will equal to 2.
Not quite. I do see what you're saying there. Like, you know, like H and S like correspondingly is like radical 3 and 2. But what is H in terms of S?
H in terms of S, that would be, wait. Yeah, how many times does does 2 go into radical 3 or 3 go
No,
into radical 3?
it's all you need to do, Ty. You're just multiplying S over to the other side. So it's radical 3 over 2 times how much?
2 times.
No, times S. You're just bringing the S over to the other side. That's all you're doing. Okay.
Right.
All right. So now that we know what H is, okay, our endeavor here. What was that? What was the first question for today's enrichment problem? Find the area.
Find the area of the equilateral triangle with side like F.
That's right.
In reduced radical form. Yeah.
So the area of the equilateral triangle in terms of S, okay, in terms of any side length, is going to equal to 1/2 S times radical 3 over 2 times S. That's the area. We can simplify this down a little bit, right? Are there any things that we can combine together?
The two S's to
The
S
2 and 2, right? And the S and S. So what will that do to me? Radical 3
over 2S squared.
No, 2 and 2 makes how much?
4.
Oh,
right? And then S times S makes S to the
S squared.
second. That's right. So this is the area of an equilateral triangle right here. And this is also something, okay, that is, I would say it's like a classic like SAT problem, or it may be possibly even an ACT problem where they ask you, to manipulate the area of an equilateral triangle. Let's try to understand what this formula is saying. If you know the side length of any equilateral triangle, all you have to do is just plug it in there. You can get the area. Okay, so say the area of the equilateral triangle, or actually the side length of the equilateral triangle is 4. What would the area be in that case?
So the side length is 4. Then it would be so that'd be 2 times radical 3 over 2 times 2. That times 4. So that'd be 2 times 2 radical. So that'd be 4 radical 3.
Yeah, it's just 4 radical 3. That's all it is. Okay, so that formula instantaneously allows you to figure out what the area of the equilateral triangle is. That's all it is. Okay, so this is the first question to today's enrichment problem. Okay, and all the subsequent questions that we're going to go over today are somewhat linked together. Okay, so let's go through the second one. Emma, can you read the second problem?
Sure. Just need to open up the other tab. All right, here we go. Find the area of a regular pentagon with the side length s in terms of sine, cosine, or tangent of the central angle.
Thank you. So we're going to find the area of a regular pentagon.
Is my camera on for you guys?
No.
Oh, yeah. My computer's been glitching out with Google Meets. I don't know why.
It's okay. All right. So a couple other things.
Maybe it's because of your connection.
Hey, Calvin,
No.
you're on.
Yeah, he's on his phone now. Something like that. Yeah.
No, I'm on my computer.
No, Kelvin is.
So guys, what's meant by a regular pentagon?
Like a just an ordinary equilateral pentagon. Well, yeah, it is equilateral.
Well, whenever we talk about a regular, like
Well,
polygon, all the sides must be what?
60 degrees.
No.
Oh, no, well, in this case, 60 degrees, but like they have to be equilateral.
All the sides must be the same. I think that's what you're going trying to go for, Ty, right?
Yeah, that's what I meant. Yeah.
All the sides must be the same length. And there's one other requirement. Not only are all the sides the same length, but all the angles
are the same length.
Must be the same. Okay?
Yeah.
So for a regular pentagon, okay, and this is my best attempt at drawing it. Okay. So for a regular pentagon, okay, all the sides are the same length. Okay, and all the angles are the same. Okay. And the question is, how do we find the area of this regular pentagon? Do you guys have any strategy or any way of thinking about this? What do you guys think?
I mean, we know that that a pentagon is 3 triangles, so we can form it into 3 triangles.
3 triangles. I do agree with you on that. So you're saying find the area of these triangles like that?
Exactly.
The only thing is, I do like that strategy. The only thing is, with that construction there, you are inadvertently creating another situation. You are creating another problem for yourself. Do you know what the issue is?
Yeah.
Yes, I do agree that it's not 90, but by the way it looks for this problem, we're not going to be working with 90 degrees here. But there's another issue that's created, okay, by creating this construction. There's a problem.
They're not 35. They're not 30, 45, or 60.
That is true. I want to let you guys know, probably because this is this problem here is a little more complex. But if you look at this, right, you see what I just highlighted there? Okay.
Yeah.
Do we know what that length is?
No.
We don't, right? So we created another problem for ourselves when we draw in a side length, okay, in a problem. And it is going to be more challenging for us to figure out what that side length is compared to, let's say, the problem from before. You know how before, like I drew a line down, right? And then like we didn't think twice, and then we just continued like working through the problem. Well, that's because the height okay, in this problem here, we can express it in terms of S. Like we can use Pythagorean theorem and we can find out what H is, right? But for this problem, okay, in this case here, is it a guarantee that this triangle here is a right triangle?
No.
It's not a guarantee, right? And as a matter of fact, we know it's not a right triangle. Okay, purely by observation, but also we can show that it's not a right triangle because all those angles there, okay, they don't add up to, they don't divide out to having something that's 90. So I'm gonna quickly actually let's try to figure this out because we'll need to know what this is anyway. So do you guys remember how to figure out what that exterior angle is? This is going back from when we were in school.
Yeah. It's it's that. Well, we don't know the exact angle, but we can subtract 180 from it. But we don't. But that's only if we have this given value. Wait. Let me see.
There's a formula, okay, or actually not a formula. There's a fact that you guys need to recall that the sum of any exterior angle. No, actually, let me rephrase that. The sum of all exterior angle for any n-sided regular polygon will always add up to a certain number. Do you guys know what that number is?
360.
That's it, right? So all these angles on the outside must be the same. I'm going to call these angles here x, right?
Mm-hmm.
So therefore, wait a minute. Each of these angles must equal to 360 divided by how much?
5.
5. Calvin, can you quickly do the math for us? What is that? What's 360 divided by 5?
Hold on for a second.
He said he put he put the answer in the chat. He said 72.
72. All right, thank you there, Ty.
Come on.
So that's 72. Okay, so that angle is 72. So therefore, what's the angle on the inside then? What's one interior angle? We're gonna do. You mentioned it. You said to take that angle and subtract from 180, right?
Yeah.
What's the measure of one interior angle then?
Let's see here. 108.
That's right. So the interior angle will equal to 108. So this is not a right triangle here. Okay. So that's why making that construction can actually complicate the situation a little more. So what I'm going to do is I'm going to step out of the box and instead step into a circle, which is kind of strange to say. Okay. So what I'm doing here is I am inscribing a pentagon inside of a circle. Okay. And what I'm going to do is I'm going to fall back on some of the things that we learned, okay, in the last week to 2 weeks to help us with this problem. Okay. So I have a circle right now, and in the circle there, I have the pentagon drawn inside. And what I'm going to do, can anyone maybe take a guess what I'm going to do with this?
Draw lines to each of the points.
Yeah. So I'm going to construct the radius. Kind of looks like the Buick symbol, right? Okay. So I have this. All right. So wait a minute. If all of these are all these triangles congruent, or are they not?
They are.
They are. What makes you say that?
Because we know that it's a regular pentagon.
I need you to be a little more precise in your language.
We know that all parts of the pentagon are congruent, so like all the lines that go into the center from each of those points should be congruent also.
Well, all of those sides that I just marked with those tick marks, okay, that they are the same because it was established in the problem as a given that this is a regular pentagon, right? So I'll give you that. Why are all the dashed lines congruent?
They're all radiuses.
They're all radiuses. That's
Radii.
right. So all of those, okay, all of those must be the same. So why are all the triangles here congruent? Again, relying back on things that we studied back in school.
Wouldn't this be SSS congruent?
That's right. So all 5 triangles there must be congruent based on SSS.
Well,
All
they're
right.
all isosceles.
What was that?
They're all isosceles.
They're all isosceles, and they're all congruent based on SSS.
Which
And
means
not
all
only
those
that,
angles are congruent.
if that's the case, then are all of these angles here going to be the same or different?
Same.
They're
They're going to be the same because of CPCTC, right? So that's wonderful. So all right, if that's the case, then okay, if I have 360 divided by 5, what's the measure of one of those angles again?
So that's 72.
That's 72. So each one of these will equal to 72.
And then we know the other angles because of if we know they're isosceles.
That's right. So if we know that these triangles are isosceles, so therefore each of these must be 54 apiece. Right?
Mm-hmm.
All right. I love that. That's 54 apiece. So let's think about this, okay? Each of the side length here measures S, right? Wait a minute.
Yeah.
Our goal was to figure out what is the area of the pentagon. So if we find out what is the area of one of these triangles, then can't we find out what is the area of the pentagon by multiplying by 5?
Yep.
Right? So that's the approach I'm gonna take here. So the area of the pentagon, right, is going to be 5 times 1/2 base times height. That's all it is, okay? All right, so what's the base of the let's observe the triangle here. I want to draw one of them out, okay? Where this is side length S, this is 54 degrees, and this is 54 degrees, and this is S, and this is S here, okay? Actually, no, those are not S. What am I saying?
Yeah.
Those are some other unknown side length, right?
Yep.
R.
That's the length of R. But I don't want to create more problems for myself because, I don't want to introduce something else that I don't know. But if I draw in the altitude right now, like so, okay, and again, this is an isosceles triangle here, okay, what's going to happen with the base? Is the base going to be bisected or is it not going to be bisected?
Bisect.
It will be bisected, so that's length S/2. I need to know what is the length of the height here. How can I do that?
You could use well, you can't really use yeah, we could use well, we don't know the length of this, so you can't see it, but I'm putting it on the side on
We
the R
don't know.
side.
We don't know this length. I agree with you, Ty.
Yeah.
Okay? But we're trying to find this, right? And we know this length. This is S/2, right? How can I find the vertical?
You could use cosine.
Cosine is adjacent over hypotenuse.
Oh, yeah, so we'd be using tangent.
Tangent, that's right. We're going to be using tangent. So therefore, again, I'm going to call this side here H. So we're going to say tangent of 54 degrees is equal to opposite, which is H, over adjacent, which is S/2. Again, it looks really complicated right now, right? And I agree with you. It looks rather scary. But again, nothing to be afraid of here. nothing intimidating about this. We're going to isolate h. We're going to cross multiply. Okay, and if we do, we'll end up with h is equal to tan of 54 times how much now?
S
What's the
over
fraction?
2.
S over 2. That's all it is. H is equal to tan 54 times S over 2. And what's the length of the base of the overall triangle of this isosceles triangle? F
S.
or S over 2?
Well, that's half of the.
That's right. We want the entire thing. What's the length? What's the base of the entire isosceles triangle?
S.
That would be S. Okay, so the base is S. So the area of the pentagon then. So the area of the pentagon is simply, it's 5 times 1/2 times S times tangent of 54 times S over 2. And again, this looks really intimidating, but just, go through things in life with a cool head and you'll come out better on the other side. So if I look at this, okay, are there any things that I can combine together?
You can combine 5 and 1/2.
Can I combine those two things?
I combine this,
Yeah.
Yeah, what will that get me?
S squared over 2.
I'll get S
That-
squared. I'm just going to write S
Make it
squared.
S if S over 2.
Now look, and what about this? Can I combine the 2 and 2?
Yes.
What will that get me?
That'll be 4.
That would be 4, and I have a 5 over here, so that will give me 5/4.
Mm-hmm.
So it's 5 S squared over 4.
Don't forget the tangent of 54, right? So the entire thing, the area of the pentagon, of a regular pentagon, okay, can be found by doing this. Area is equal to 5/4.
But how can we
what?
how are we going to abandon S over 2 like that?
Because we have the twos. We have 5 halves and we have 1/2, and we have the same denominators.
Right. So Emmett, and so is S over 2 the same thing as 1/2 times S? Like, is that the same thing? Is S over 2 the same thing as 1/2 times S?
Yeah.
It is, right?
Yeah.
So because of this, okay, that's what's allowing me to combine the 1/2 and, that 2 there to get 1/4. And then 5 times 1/4, what is that?
5/4.
That's just 5/4. That's all it is. Okay, so that's the area of the pentagon. Okay, so again, this formula, if you know the side length of a pentagon, okay, you can immediately figure out what is the area of that pentagon. Cool?
Mm-hmm.
All right, let's try that again, okay? What's the third question here?
Number 3 is find the area of a regular hexagon with side length S in reduced fractal form.
Okay, so for a regular hexagon this time, okay, so I have this. What can we do to find out what is the area of a regular hexagon? And again, I'm going to do something really similar here, and we can actually rely on some of the information that we had figured out during today's enrichment session. What can I do? How can I use some of the things that we figured out in today's enrichment session to help us find the area of a regular hexagon?
Well, you know that these triangles are isosceles.
We know that they're isosceles, but we know something even more specific. Not only are they isosceles, they are what?
They're all congruent. CPCCC congruent.
They are indeed all congruent. I will give you that. But there's something else even more, okay, to this. And that something is if I take this hexagon, right, and do the same thing and inscribe it inside of a circle like so, okay, you're going to see that all those dashed lines that I drew in the diagram on the left there, they must be what?
They add up to 360.
They have to be the same, right?
Yeah.
All of these lines, they have to be the same because they end up being the radius of the circle, right?
Yep.
So wait a minute. If they're all the same, right? What am I going to divide 360 by to figure out what each of these interior angles are?
6.
60. Thereby making each one of those angles how much?
60.
60. Wait a minute. If these are all 60,
It's an equilateral triangle.
then this must be an equilateral triangle. These angles over here must also be 60. Everyone follow that?
Yep.
Oh, so that means the S's are, so it's the same as the other one, just
That's
times
right.
6.
Okay. So the area of a regular hexagon, okay, is going to be 6 times, right, the area of the equilateral triangle, as we've discussed there. Do you guys remember what that is?
Radical 3 over 4.
That's
S
it.
squared.
So the area of a regular hexagon, and it doesn't matter what the side length is, because that's the formula. We can actually simplify this just a little bit. Is there a common factor between 4 and 6?
Yeah.
2.
2, right? So this becomes 3 radical 3 over 2 times s squared. This is the area for a regular hexagon. That's really neat. Do you guys see some commonality between each one of these formulas? Each one
Yeah,
of
they all love
these each one of these formula all have an s squared in it. Do you guys notice that?
Yep.
Yeah.
They all have the s squared in it, and the difference is, okay, is a matter of how much we're multiplying with the s squared, and that factor on the outside, the factor being this, right, really dictates what the area will turn out to be. Okay. Anyway, so I'm just trying to point out some like commonality between all the formulas here. And what's the last formula that we're going to try to come up with for today?
Find the area of an n-sided regular polygon with the side length s in terms of sine, cosine, or tangent of the central angle.
All right, so we're
They don't
gonna
give us the side, like the amount of sides that.
that's right. We're gonna take an intellectual leap here now, guys. A really big one, because we went from a polygon with 3 sides to a polygon with 5 sides, a polygon with 6 sides. Now we're going to try to figure it out for a polygon of n number of sides. Okay, so area for polygon, for regular polygon, I should say. And this will be the last thing for today. Regular polygon with n sides of length s. Okay, so if we approach this, okay, in the same manner, do you guys see the what I did here in the last 2 problems? I took the polygon and I inscribed it in inside of what shape?
A circle.
A circle. So I want to do the same thing here, okay? But what I'm going to do is, what I'm doing here is I am doing this now for any number of sides. So I'm just drawing, some number of sides here. And the trick always has been, okay, or not trick, but rather a technique, right, has been to connect all the corners to the center. Isn't that right? That was what we did, right?
Yes.
Okay.
So
but how do we know
to inscribe in there if we don't know how?
You're right. We don't know. Wait, what was the question again?
Like, how do we know how to?
Emmett?
And
Have the. Can you hear?
How do we know how many triangles? Is that the question?
No, like
you're a bit choppy.
how do we know how many sides?
Right. We don't know how many sides, okay? But we're just creating some n number of sides. I'm trying to be as general as possible, right? So let's say if I have n number of sides here, okay? The technique has been to find out what are all of these angles on the inside. Wasn't that right? And what we would do is
Yeah.
we would take 360 and divide by how much?
N.
N. That's right. We take 360 divided by n. Okay. And then after we did that, we found out what the central angles are, right? And then after finding out what the central angles are, okay, then we try to find out what that angle is. So imagine this with me, okay? This angle over here and this angle over here, are they going to be the same length or are they going to be the same measure or different measures? They are going to be the same measures, okay? So I don't know what they are, so I'm just going to call them like 2x, okay? Because they're the same, right?
Yeah.
So I'm going to call them 2x. So if that's 2x, 2x plus 360 over n, what must that equal to?
720x over n.
No, we can't. No.
It's not multiplying. It's not multiplying. My bad. My bad.
So look, what I'm asking is this angle plus this angle plus this angle must add up to how much?
360,
All three angles in a triangle must add up to how much?
180.
That's it. I got to figure out what is that unknown angle x, okay? So if I do that, I'm going to subtract both sides by 360 over n. And lastly is I'm going to divide by 2. If I divide by 2, what's 180 divided by 2, guys?
90.
90.
And what is 360 divided by 2?
180.
180. So 180 over n. So this right here, okay, that's the measure of the angle, okay? That's x. So if I look at the last problem I did, like 2 problems ago, okay? I found out the base angle, okay? I found out the base angle, okay? And the base angle right now is this guy right here, and that is 90 minus 180 over n, right? That's the base angle. And what's the length of half that base?
45 minus
Well, what is the length? What is the length of one of the sides of the what is
half
the
that.
length of one of the sides of the Pentagon again?
One of the sides of the Pentagon, that was S.
It was S, right? So, or actually polygon. So here in this case, okay, if I'm looking at just one of these triangles, okay, then that means half that base is going to be S over 2. And I need to know what is the height now, right? What function am I going to use? Am I going to use sine, cosine, or tangent to figure out what that h is?
Tangent.
I'm going to use tangent. So I say h over s over 2 will equal to tangent of 90 minus 180 over n. And we're in the home stretch, okay? So we're going to multiply both sides by s over 2. We have h is equal to s over 2 times tangent of 90 minus 180 over n. So that's the height of one of the isosceles triangles, okay? And how many isosceles triangles do we have? Don't say 8.
N.
We have n number of isosceles triangles. That's right, okay? So that means the area is going to be n, because that's the number of isosceles triangles that we have, times, what's the area of one isosceles triangle? It's 1/2 times, what's the base?
The base would be S over 2.
Just S, right? Times, what's the height?
Tangent 90 minus 180 Yeah.
Yeah.
So I mean,
You know how,
essentially,
like,
you're
in
not.
movies, how in movies you see these like mad scientists, they're writing like all this stuff on a blackboard, and they're
Mhm.
getting like all these different formulas from one place to another, right?
Yeah.
It's not. I mean, like that is all fictional, okay? But in the real world, like if you walk into like a math like lab, okay, where they or any type of like physics lab or chemistry lab, okay, there will be formulas all over the board, and that's a language, okay, that they're speaking, that they're communicating with you guys. So anyway, look, there are things that I can combine together, okay. I have S, and S makes how much?
S squared.
That makes S squared, okay. There's that common feature again, okay, that comes up. All right, and then now I have 1/2 and 2, and that gets me how much?
To 1/4. But then,
1/4.
like, can you make it n over 4?
You can. So it's n over 4 times tangent of 90 minus 180 over n. So this, gentlemen, is the area formula for any polygon with a side length of S. Okay?
Right.
All right. So I'm going to leave you with that. That was kind of cool, right? Maybe.
Mhm.
I'm going to stop recording.